There's something deeply satisfying about a machine that runs smoothly. No hesitation, no strange rattles, no smoke where it doesn't belong. Cars, in particular, have a way of telling their story through their performance. An engine that's been cared for responds like a trusted companion, strong, reliable, and ready to go when you are. Unfortunately, too many drivers unknowingly shorten their engine's life by overlooking essential maintenance steps. They may think, "It's running fine now, so why mess with it?" But engines don't fail in a single dramatic moment. They fade slowly when neglected. If you've been feeling that your vehicle just doesn't have the same pull, the same responsiveness, or the same sound it used to, it's not necessarily because it's getting old. In many cases, the right care can restore much of its original vigor. Today, we're going to go through the proven maintenance habits that can make your engine feel like it's fresh off the factory floor. Regular oil change. Keeping your engine in peak condition begins with consistent oil changes. Fresh oil maintains a protective film between moving parts, reducing wear and preventing heat buildup. Over time, oil degrades due to exposure to high temperatures and the constant mechanical stress of operation. It also collects impurities such as dust, metal shavings, and combustion residue, which can circulate through the engine if not addressed. This buildup compromises lubrication and can accelerate component damage. Following your vehicle manufacturer's recommended interval is crucial. For some older models, this may be around 3,000 miles, while many newer vehicles can safely go 7,500 miles or more before needing fresh oil. The choice of oil type matters as much as timing. Conventional oil works for standard driving conditions, but synthetic blends and full synthetics often provide superior protection, particularly under heavy loads, extreme temperatures, or long driving sessions. An often overlooked step is replacing the oil filter during every oil change. The filter traps contaminants before they reach sensitive engine parts, but once it becomes clogged, it restricts oil flow and allows debris to bypass filtration entirely. Neglecting this step can quickly erase the benefits of using fresh oil. Synthetic oils deserve special mention for their resilience under heat and their ability to maintain viscosity over extended intervals. They also resist sludge formation, keeping internal passages clean. While they may cost more upfront, the investment often pays off through reduced wear and a longer engine lifespan. Ultimately, the consistency of oil changes directly impacts how well an engine performs and how long it lasts. Each scheduled change flushes away accumulated debris and replenishes the lubrication system with clean, high-quality oil. This simple yet disciplined practice protects moving parts, maintains efficiency, and minimizes the risk of costly repairs. By staying committed to proper oil maintenance, you create the best conditions for your engine to operate at its full potential over many years of service. Cooling system maintenance. The cooling system regulates engine temperature, preventing heat from reaching levels that could cause severe damage. It works through a coordinated system of components, including the radiator, water pump, thermostat, hoses, and coolant, to transfer excess heat away from the engine. Without proper care, these parts can fail, leading to overheating and costly repairs. Checking coolant levels should be part of regular maintenance. Always use the correct type of coolant specified for your vehicle, as different formulations offer varying protection against corrosion and temperature extremes. Alongside this, inspect all hoses for cracks, bulges, or leaks that could compromise coolant circulation. Even a small leak can rapidly lead to overheating. Flushing the cooling system at manufacturer-recommended intervals, typically every 2 to 5 years, helps remove rust, scale, and other deposits that reduce efficiency. During this process, fresh coolant restores optimal freeze and boil protection. Seasonal changes, especially approaching winter or summer, are ideal times to test coolant performance to ensure it can handle the temperature range ahead. If the temperature gauge begins to climb above its usual position, prompt investigation is essential. Delaying action can result in warped cylinder heads, blown head gaskets, or even total engine failure. Preventive care of the cooling system is a direct safeguard against these risks, keeping the engine in a safe operating range at all times. Air filter and fuel system. Feeding the engine properly. A steady supply of clean air and quality fuel is essential for efficient combustion. The air filter traps dirt, dust, and debris before they enter the engine. Over time, it becomes clogged, restricting airflow and reducing power output. Replacing or cleaning it at recommended intervals, or more frequently in dusty conditions, ensures maximum airflow and efficiency. Fuel quality plays an equally important role. Using fuel from reliable stations reduces the risk of contaminants reaching the injectors and combustion chamber. Over time, carbon deposits can form on injectors, valves, and chamber surfaces, impairing performance. Periodic use of a fuel system cleaner can help prevent buildup and maintain smooth operation. Symptoms such as hesitation, misfiring, or rough idle can indicate fuel delivery problems. Addressing these issues promptly ensures consistent combustion, smoother acceleration, and improved fuel economy. Proper air and fuel system maintenance keeps the engine operating at peak efficiency while minimizing long-term wear. Spark plugs and ignition system. The ignition system is responsible for initiating combustion at precisely the right moment. At its core are the spark plugs, which must generate a reliable spark to ignite the air-fuel mixture inside the cylinders. Over time, these plugs can wear out, accumulate carbon deposits, or become contaminated with oil, all of which reduce their ability to perform efficiently. Regular inspection of spark plugs is essential. Look for signs such as eroded electrodes, excessive buildup, or discoloration. The replacement schedule varies depending on the type of plug installed. Copper plugs may need changing around every 30,000 miles, while platinum and iridium variants can last well beyond 100,000 miles when used in optimal conditions. Proper gapping is another critical factor. If the gap is too wide or too narrow, the spark may weaken or fail entirely, leading to misfires and loss of power. Checking and adjusting the gap according to manufacturer specifications ensures consistent ignition. The rest of the ignition system should not be overlooked. Ignition wires, coils, and related components must be in good condition to deliver the necessary voltage to the plugs. Faulty parts can cause rough idling, hesitation during acceleration, or reduced fuel economy. Replacing worn spark plugs often results in immediate improvements in throttle response, smoother operation, and more reliable cold starts. This simple maintenance task plays a significant role in overall engine health and performance. Listening to your engine. Engines provide early warnings through changes in sound, vibration, and even smell. Recognizing these signs quickly can prevent minor problems from becoming costly repairs. A knocking or pinging noise during acceleration can indicate pre-ignition or detonation, often linked to poor fuel quality, excessive carbon buildup, or incorrect ignition timing. A persistent ticking or tapping sound may signal valve train wear or lifter issues that require mechanical adjustment or replacement. Unusual smells also carry important clues. A burning oil odor suggests that oil is leaking onto hot engine components, potentially from worn gaskets or seals. A sweet, syrup-like scent from the exhaust may point to coolant entering the combustion chamber, often due to a failing head gasket. By staying attentive to these indicators and investigating changes promptly, it is possible to address problems early. This proactive approach helps preserve engine performance, extend component life, and avoid more extensive mechanical failures. Using additives wisely. Additives can be a beneficial part of vehicle care when used correctly and with a clear understanding of their purpose. They are designed to complement routine maintenance, not replace it, and can target specific issues within the fuel or lubrication systems. Selecting the right product and following proper usage guidelines is essential to ensure effectiveness and prevent unintended side effects. Fuel additives are commonly used to maintain and restore the cleanliness of fuel delivery components. Over time, deposits can form in fuel injectors, intake valves, and combustion chambers, reducing efficiency and performance. A well-formulated fuel additive can help break down these carbon deposits, leading to smoother combustion and more consistent power output. It is important to use these products only as directed by the manufacturer to avoid excessive chemical concentration, which can damage seals or sensors. Periodic use, especially before long trips or after extended periods of low-quality fuel use, can help maintain system cleanliness. Oil additives serve a different function. In older engines or those with high mileage, they can enhance lubrication by improving oil viscosity stability under high temperatures and mechanical stress. Some oil additives are formulated to reduce friction, which can minimize wear on critical components. Others may address specific concerns such as excessive oil consumption, minor leaks, or noisy valve lifters. These can temporarily improve performance and reduce operating noise while extending the time before more significant repairs are required. Product quality and compatibility should be priorities when selecting additives. Reputable brands generally provide detailed information about suitable applications, chemical composition, and any limitations. Consulting the vehicle's owner manual or a trusted mechanic before introducing an additive helps ensure it will not interfere with existing lubricants, coolants, or fuel properties. While additives can deliver measurable benefits, They work best when paired with consistent oil changes, quality fuel use, and overall proper engine maintenance. When applied thoughtfully, they can extend component life, enhance performance, and provide extra protection against wear and buildup, supporting the engine's operation under various driving conditions. Battery and electrical system. The battery and electrical system form a critical support network for engine operation, powering ignition, fuel delivery, and numerous sensors that regulate performance. A weak or failing electrical system can lead to starting difficulties, inconsistent engine behavior, and even complete breakdowns. Maintaining these components ensures the engine receives a steady and reliable power supply at all times. Battery maintenance begins with clean, secure connections. Corrosion at the terminals can restrict current flow, causing intermittent issues that may be mistaken for mechanical problems. Cleaning the terminals with an appropriate solution and applying dielectric grease afterward helps slow down the formation of new corrosion. This simple step can prevent voltage drops that affect the function of critical systems. Regular testing of battery health is equally important. Batteries naturally lose capacity over time, and extreme temperatures accelerate this decline. Testing before winter is especially valuable, as cold conditions require more starting power while simultaneously reducing battery efficiency. A preventive replacement before complete failure can save time and avoid roadside emergencies. The alternator plays a key role by recharging the battery and powering electrical components while the engine runs. If the alternator is not charging at the correct voltage, the battery will deplete even during normal driving. Signs of alternator issues include dimming headlights, slow accessory operation, or warning lights on the dashboard. Periodic voltage checks ensure the charging system is operating within the correct range for your vehicle. Cables and wiring should also be inspected for wear, loose connections, or damage. Electrical integrity is essential for consistent signal transmission between the engine control unit, sensors, and actuators. Neglect in this area can lead to misfires, poor fuel economy, or erratic engine performance. A strong electrical system not only ensures reliable starting, but also maintains stable operation for advanced engine management systems. By keeping the battery, alternator, and wiring in optimal condition, the entire engine benefits from a consistent and dependable power supply, supporting efficiency, performance, and longevity. Restoring smooth operation. The throttle body and mass airflow sensor are essential components in regulating the air entering the engine. They directly influence how smoothly the engine responds to driver input. Over time, these parts can accumulate dirt, oil residue, and carbon deposits, leading to performance issues such as hesitation during acceleration, unstable idle, and reduced power output. The throttle body contains a plate that opens and closes to control airflow. Deposits can build up along the plate edges and housing, restricting movement and disrupting airflow precision. Cleaning this part requires removing the intake ducting and using a throttle body-specific cleaner to dissolve and remove the buildup. Care must be taken to avoid damaging sensors or gaskets during the process. Allowing the cleaner to work into tight areas ensures the plate moves freely again, restoring smooth airflow and throttle response. The mass airflow sensor measures the volume and temperature of incoming air, sending data to the engine control unit for accurate fuel delivery. Because of its delicate internal wires or film, it must only be cleaned with an MAF-specific cleaner. Using the wrong product can permanently damage the sensor. Cleaning involves carefully removing the sensor, spraying the cleaner without touching the sensing elements, and allowing it to dry completely before reinstallation. This helps restore accurate readings, improving fuel efficiency and performance. Regular inspection and cleaning of these components can prevent the gradual decline in responsiveness that often goes unnoticed until severe. Issues such as erratic idling or delayed acceleration are frequently resolved after thorough cleaning, without the need for costly part replacements. Maintaining a clean throttle body and MAF sensor ensures the engine receives the correct air supply under all operating conditions. This not only improves drivability, but also supports better fuel economy and reduced emissions. By addressing buildup early and performing careful cleanings at recommended intervals, the air intake system continues to function at peak efficiency, contributing to a smoother, more consistent driving experience. Proper break-in for new or rebuilt engines. The initial operation of a new or rebuilt engine plays a significant role in determining its long-term performance and reliability. During the first several hundred miles, internal components such as piston rings, cylinder walls, bearings, and camshafts need time to wear in and conform to one another. Proper break-in procedures help achieve optimal sealing, reduce premature wear, and extend overall engine life. One key principle is to vary engine speed and load. Operating at the same RPM for extended periods can prevent piston rings from seating correctly. Instead, drive in a way that changes engine speed frequently, using a range of gears and moderate acceleration. This variation promotes even wear across moving surfaces and helps establish proper oil film patterns. Avoid heavy throttle use, high RPM operation, and towing or hauling heavy loads during the break-in period. These conditions place excessive stress on new components before they have fully adapted to each other's surfaces. Gradually increasing load over time allows the engine to strengthen its contact points without causing damage. Oil changes are critical during this stage. Freshly machined or rebuilt engines can produce higher amounts of metal particles as surfaces smooth out. Following your engine builders or manufacturer's specific recommendations for the first oil change, often within the first 500 to 1,000 miles, helps remove these particles before they can circulate and cause damage. Using the correct oil type and viscosity during this period is equally important, as break-in oils may be recommended to promote proper ring seating. Temperature management also plays a role. Ensure the engine reaches full operating temperature during drives, as this allows components to expand and seat properly. However, avoid prolonged idling, as it does not create the varied load conditions necessary for effective break-in. By following these guidelines with precision, piston rings achieve a proper seal against the cylinder walls, bearings wear evenly, and all mating surfaces develop optimal contact patterns. This careful approach in the early stages establishes a strong foundation for reliable performance, improved efficiency, and reduced wear over the entire service life of the engine. Consistency over time. Sustaining peak engine performance is the result of disciplined and regular maintenance. Every service task, from oil changes to spark plug replacements, contributes to the overall health of the vehicle. These actions work together over time to minimize wear, prevent buildup of harmful deposits, and keep systems operating within their intended parameters. Oil changes performed at the correct intervals ensure that internal components are continuously lubricated and free from the abrasive particles that naturally accumulate during operation. This reduces friction and heat, both of which can accelerate wear. Coolant flushes remove rust, scale, and chemical degradation byproducts that could compromise the engine's temperature regulation, preventing overheating and the costly damage it can cause. Spark plug replacements maintain efficient combustion by ensuring a strong, consistent ignition spark. When plugs degrade, they can cause misfires, rough idling, and poor fuel economy. Replacing them on schedule restores smooth operation and optimal fuel burn. Similarly, air and fuel filter changes protect the engine from contaminants. A clean air filter maintains proper airflow for combustion, while a clean fuel filter ensures unobstructed delivery of fuel to the injectors. Transmission and brake fluid services are also part of long-term consistency. Transmission fluid keeps gear changes smooth and prevents premature wear of internal components. Brake fluid replacement ensures proper hydraulic pressure for safe and responsive braking, while also preventing moisture-related corrosion within the braking system. Even for those who have overlooked maintenance in the past, starting a consistent routine now can yield measurable benefits. Engines that have suffered from neglect may still regain noticeable performance, efficiency, and reliability when given proper care. Cleaning intake components. Replacing worn ignition parts and restoring fluid condition can revive responsiveness and reduce mechanical strain. The key is not relying on a single major repair or upgrade to restore performance, but rather committing to a schedule that keeps every system in balance. Skipping even one element can undermine the effectiveness of others. For example, fresh oil cannot perform its function fully if the cooling system is compromised, and a clean air filter will not optimize combustion if the ignition system is weak. By keeping to a consistent maintenance schedule over months and years, a vehicle can maintain strong performance well beyond the average lifespan. This approach safeguards against costly breakdowns, preserves efficiency, and ensures the driving experience remains smooth and dependable. A smooth, strong, and dependable engine isn't a matter of luck. It's the result of consistent attention to the small things. From oil changes to spark plugs, from listening to unusual sounds to cleaning the throttle body, each step plays a role in keeping your car running like it did when it was new. If you've noticed your engine feeling tired, these maintenance steps can breathe life back into it without the cost of a full rebuild. Before you go, I'd love to hear from you. What's the one maintenance habit you swear by that's made the biggest difference in your car's performance? Share it in the comments. And if you found this video helpful, make sure to like, comment, and subscribe so you never miss more in-depth automotive tips that can save you time, money, and frustration.